So let's say you are seated peacefully in the exam, minding your own business, and they decide to ask you a situation like this one. It says the first term of a geometric series is 14, and the sixth term is 448. Calculate the value of the constant ratio. So before we can do anything, we need to tell them what they told us. They said to us the first term, which we understand is the value of A, they said it's 14. And furthermore, they said the sixth term is 448. This is what they said. But most importantly, they said this is a geometric series. So how do we define term number 6? It's just A times R to the power 6 minus 1. And 6 minus 1 will simply give you 5. And then you equate this to 448. Then you say, what is A? Well, A is just 14. And then you times this by R to the power 5. And this is equal to 448. Then you divide both sides by 14. You find that R to the power 5 will simply be 32. And then you realize that 32 can be written in exponential form to base 2. So this is 2 to the power 5. Then you say, if the exponents are the same, well, the bases are bound to be the same as well. So that will be your constant ratio. Well, of course, there are many ways to kill a cat. You could have decided to introduce the fifth root on both sides. You'll still get 2. Or you could have decided to raise both sides to the 1/5. You'll still get 2 even if you do that. But this is the value of the constant ratio. So let's see what the next question says. It says, determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum of 114,674. Do you see that? So the word consecutive tells us that the terms must follow each other. But what is this 114,674? It's the sum for the total number of terms. Do you see that? So the easiest way to approach this is to calculate the total number of terms, which if we add together, give us a value of 114,674. Then we say, if maybe we know that we have 15 terms, then we say 15 minus 6 will give us 9. That 9 is the one the question is looking for. Are we fine? So let's go to the whiteboard and do that. So what did we say? We said the sum of the total number of terms is 114,674. But since this is a geometric series, we know that this is how we calculate the sum of a number of terms. So this is what we are going to say. And then we say the value of A is 14. The constant ratio is 2. We are looking for the number of terms. And then we say minus 1. In the denominator, we say 2 minus 1. Well, I'm just going to omit that part because 2 minus 1 is simply 1. And then we say everything is set equal to 114 674. Then from this point, we divide both sides by 14. So we say 114,674 divided by 14. On the left-hand side, we are left with 2 to the n minus 1. And this is equal to 8191. And then from this point, we take this one to the right. It becomes positive. So the total sum becomes 8192. So if we write 8192 in exponential form to base 2, it's just going to be 2 to the power 13. Do you see that? So we say when the bases are the same, we equate the exponents. So n will just be 13. But what is this 13? It's the total number of terms, which if we add together, the sum will be 114,674. But what did the question say? It says, determine the number of consecutive terms that must be added to the first 6 terms in order to obtain a sum of that. So it means we already have the first 6 terms inside the 13. Then we'll say this number of terms, it's 13 minus 6, which will give us 7. So 7 terms must be added to the first 6 terms in order to obtain a sum of this much. Do you see that? Right. Now let's look at the next question. So this one says, if the first term of another series is 448 and the 6th term is 14, calculate the sum to infinity of the new series. So if you observe well, you can see that they actually swapped the numbers around, because in the original sequence, or rather the first one, the first term was 14, but now 14 is the 6th term. Do you see that? So we start where we started. We tell them that the first term is 448 and that the 6th term is 14. Then we define term number 6 as AR to the power 5. And this is equal to 14. But the value of A, we understand it's 448 times R to the power 5. And this is equal to 14. Then from this point, we divide both sides by 448. So we find that R to the power 5 will be 1/32. Then from this point, we introduce the 5th root on both sides so that the root and the power will cancel out. So the constant ratio will simply be a half. And here we can see that the value of R is less than 1, but greater than -1. So indeed, a sum to infinity exists. So remember, in order for you to find the sum to infinity, you don't need to know many things. You just need to know your first term as well as your constant ratio. So you say term number 1 is 448. The constant ratio is 1/2. So if you say 1 minus half, you get a half. And 448 divided by half is the same as 448 multiplied by 2. So here you simply get 896. and then your happiness is complete. So what about the last one? What does it say? Let's give it a good look. So the last one says, if the sum of a series represented by the general term 1 over 3p plus 1 over 6 from p equals 0 to p equals k is 20 and 1 over 6. Determine the value of k. So the question we need to ask is, what is k? K is not the number of terms, but instead, it's the last value we substitute when expanding this series. Very important. But in order for us to get the value of k, we need to go to the number of terms. So this is what the series is saying. It's the sum of a series represented by this general term from from p equals 0 to p equals k. And they said to us, the sum will be 20 and 1 over 6. So this one, we can see it's a mixed fraction. So we hate mixed fractions. We want to work with improper fraction because it's easier to do so. So you say 20 multiplied by 6, you get 120. And then you say 120 plus 1. So you get 121 over 6. This is your sum. So the first thing we need to do here is to expand our series so as to generate the first 3 terms. So we have 1 over 3 into 0 because we start by substituting p equals 0, and then we substitute p equals 1, and then we substitute p equals 2. Then we show them that we have added so many terms in between up until we got to the last term, which we obtain by substituting p equals k. Do you see that? Then you go to your calculator and say 1 over 3 into 0 plus 1 over 6. So you find that the first term is 1 over 6. In order to get the second term, you substitute p equals 1, so you get a half. In order for you to get the third term, you substitute p equals 2, so you get 5 over 6. And this goes all the way to the last term, which we obtain by substituting p equals k. This is what we have. Then from this point, if you say half minus 1 over 6, you get a third. 5 over 6 minus half, you also get a third. So it means the constant difference will be 1 over 3. So what about the number of terms? In sigma notation, we take the top value, then we say minus the bottom value, and then we say plus 1. So it means the number of terms are equal to k plus 1. So if I know the number of terms, I can easily find the value of k. Do you see that? So let's use the formula which I like. We say the sum of a number of terms equals n over 2 into 2a plus n minus 1 times d. This is what we have. So we don't know the number of terms, but the sum is given to us as 121 over 6. Then we still have n over 2. Then we say the first term is 1 over 6. The number of terms is unknown, but the constant difference is a third. This is what we have. We still keep this one as it is, and then we want to simplify the bracket. So 2 times 1 over 6, we get a third. And then here we distribute the 1 over 3. This is what we say. So 1 over 3 times n, it's 1 over 3n. And 1 over 3 times negative 1, it's negative 1 over 3. We still have 121 over 6. We still have n over 2. And then we realize that this one and that one will commit suicide. So we are left with 1 over 3n. Of course, 1 over 3n can be written as n over 3. So I'm going to do that. Then from this point, what is going to happen? Well, I still have 121 over 6. And then we say numerator by numerator, we get n squared. Denominator by denominator, we get 6. You can't cross multiply here, guys. People have a tendency of cross multiplying. Imagine you saying n multiplied by 3 and then 2 multiplied by n. You don't cross multiply, right? So from this point, you say, if the denominators are the same, well, the numerators are bound to be the same as well. Then you introduce the square root on both sides. You find that n is negative 11 or n is positive 11. But of course, you have to cancel this one out because it's a negative value. So this is the number of terms. Now that we know the number of terms, then we remember the relationship between the number of terms and the value of k. So this is what we said. Do you see that? So if the number of terms is k plus 1, then k will be the number of terms minus 1. So this means the value of k will be a solid 10. And then your happiness is complete. So you could have done it using the formula that I like, or you could have used the second formula because you actually have the last term. What is your last term? It's 1 over 3k plus 1 over 6. So let's use the second formula. So you say A plus L, like that. Well, the sum is still the same. It's 121 over 6. Now the number of terms, because your last term is given in terms of k, it makes sense for you to express your number of terms in terms of k as well. So you say where you see n, you actually see k plus 1. And then you say this is divided by 2. And then you say the first term is 1 over 6. The last term is 1 over 3k plus 1 over 6. So if you simplify the bracket, 1 over 6 plus 1 over 6 is a third. So you have 1 over 3k plus 1 over 3. Do you see that? And instead of me writing 1 over 3k, I'm simply going to write this as k over 3. Well, of course, the sum is still the same, 121 over 6. Then what do we say? We come to this part, we simplify once again. We know that if the denominators are the same, we add the numerators. So we still have 121 over 6, and then we still have k plus 1 over 2. But then when we add the numerators, this is what we get. So we say it's k plus 1 divided by 3. Do you see that? And then here you can say you have 121 over 6, which is equal to what? Then you multiply these two, numerator by numerator, denominator by denominator. So k plus 1 times k plus 1, you can write this as k plus 1 squared. Or you can expand it if you like. And then you say 2 times 3, you get 6. Then once again, you said, if the denominators are the same, the numerators are bound to be the same. In order to solve for k, we have to introduce the square root on both sides. Do you see that? So you'll decide which one is easier for you to work with. So after introducing the square root, you have to get plus or minus 11, right? But there's no need for you to focus on the negative solution. Anyway, it's not a solution for k. And then the square root and a square will cancel out. So you are left with k plus 1. And then you take this one to the left, it becomes negative. So this means the value of k is a solid 10. Over and out.